So we're going to go through each of these parts one at a time. I'm going to kind of show you what I'm looking for and what I'm doing. And then I'll have you guys take a stab at it. Okay, so A. I want to know as the cat, so here's the situation. We got a cat sitting on a table named Pickles. Okay? Or maybe Mr. Moon Muffin or something like that. Ooh, I like that. Mr. Moon Muffin. Okay, so this is Mr. Moon Muffin. Then we've got a car at a constant speed, and we've got a car accelerating forward. Okay? I want to know for A, is it at equilibrium? So is it at mechanical equilibrium, and why do you say that? So the answer is just going to be yes or no. Yes or no for A, yes or no for A, yes or no for A. As a reminder, what's mechanical equilibrium? Who remembers? Oh, what? This is not great. Okay, yeah, Jolie.
Equal opposite forces. It's not going to go anywhere.
So it's balanced. Equilibrium means net force is 0. So what I mean by equilibrium, I'll write this up here. So what I mean by equilibrium is that the net force is 0. Okay, that's what I mean. I want you to look at 1, 2, and 3 and ask yourself, is the net force 0? Okay? And write that in for A for each of these. So take a minute, do that, see what you can find out. All right, Noah. Is the cat at equilibrium? So Mr. Moon Muffin, is he at equilibrium? Good. So he is at rest, or he is at equilibrium, yes. And the reason is he's not moving, so he's at rest. Good.
Thank you.
All right. When that happens, so if something's at equilibrium, here's what I want you to think and do. I want you to think it's at equilibrium, net force is 0, and next to the object, I want you to write F net equals 0. So if the object is at equilibrium in any problem you do, if it is, I want you to write F net equals 0 next to it. Okay? All right. Next one, Liz. What about the car at a constant speed? Is that at equilibrium? Which one?
I'm going to say yes.
Okay, why?
Is that
Yes, so it's not changing. It's at a constant speed, so it's not changing. If it is constant, it is going to be, and I'm going to write it again here, F net equals 0. So, this is true all the time. If there is a net force, if an object's at equilibrium, the net force is 0. Remember, Newton's first law. Objects in motion remain in motion. Okay? Constant speed. Stays at a constant speed. Objects at rest remain at rest. Sits at the table. Unless acted on by a non-zero net force. These are 0 net forces because they're in equilibrium. Okay? So that's 1, the cat sitting at rest, constant speed, equilibrium. Car, constant speed, equilibrium. Jolie, what about the accelerating car?
no,
Why not?
because it has more supply than friction.
Yes, so there is going to be some net force to make it accelerate. So this one is not in equilibrium. And the reason is it is changing speeds. It's accelerating. Okay. Now, as soon as you get to a problem like this, as soon as you see there is a net force, it's not 0, you need to draw the direction it's in. You need to draw the direction of the net force. Figure out which way is it going. Okay? So Mason, which direction do you think the net force is on this car? So which direction is it changing? So it's speeding up. So which direction is the change going to be? Forward. So you would draw an arrow to the right. I'm drawing it as a double arrow just to differentiate it from the next couple of arrows I'm going to draw. And I'm just going to write FNet next to it. So here is step one on all of these problems. Okay, step one on all these problems. Ask yourself, before you do anything else, is it in equilibrium? If it is, write the net force is 0. If it's not, draw the direction of the net force. If you don't know, and there might be a problem where you just have no idea which direction the net force is, it should usually be kind of obvious, but it may be difficult. Always just take your best guess. If you're not sure, draw it to the right. Yeah. And if you're wrong, you'll get a negative answer, and that's fine. Okay? But that should at least get you the first step. So step one, decide if it's in equilibrium. If it is, write FNet equals 0. If it isn't, draw the direction of the net force. All right, step one.